Hey guys, welcome back to another modern binary exploitation video. So this is part two, and if you have not uh, watched the part one, I will suggest that you watch that part one, where I have covered two challenges, Crack Me 1 and Crack Me 2, and in this video I will cover Crack Me 3 and 4. And before I do that, I will briefly talk about the overview slides, which was the first PDF in this course. For some reason, I have not covered in the previous video, so ideally I should have covered it there. But anyways, I will cover it here. And if you want to skip this part, you can just skip next 3 to 4 minutes of this video, and there you will begin with the Crack Me 3 and Crack Me 4. So in the first day, the lecture slides are as follows. So let me scroll up from the top. So in the beginning, um, just they have given some basic overview, but what I want you to uh, briefly study is to look at these suggested textbooks. So these three books are suggested, which are related to exploitation and binary analysis. So just you can have those books. Then the next important part is the terminology. If you're not familiar, you can read all these. And uh, the most important part is the overview of instructions and the architecture. So the language depth is shown here. So while we are working on C language, we are here. This is called low level language, and this is the assembly code, and this is the machine code, and then the hardware comes. So wherever we see the hex format, that is the machine code, and the assembly code is more on the instruction view. So whenever we see the instruction code like add, subtract, or move, or jump, so all those are comes here. And then on top of it, the code is compiled, the C code is compiled to instruction version so that machine can understand. If we want to roll it back, we need to decompile the assembly code, which we will briefly cover in this video. And then the middle level is C sharp and C++, Java, and high level is obviously Python, Ruby, JavaScript, and many more languages. So next is this is the C program example. So uh, they have shown one small example just to print hello world. And next is uh, the compilation. They're compiling using the GCC, and the memory manipulation example, where some um, buffer will be created and some value will be stored. So this is just a very basic example. And I'm skipping this part. So this is another program, and they have shown the example of buffer overflow. uh, and then this is the assembly code. So starting from here, you need to understand that there are two type of syntax. One is Intel syntax and other is AT&T syntax. In this PDFs, Intel syntax is used, where source is written on the right side and destination on the left side, and whatever the operation is getting executed. So 5 will be moved to this destination EEX register. And in the AT&T, it is opposite. So source is mentioned here and destination is here. So we'll be using Intel in this class. And this is the register diagram. Just an overview that we have these type of register, and these are some flags and important register details you can read. And this is the moving data instruction. So in order to understand uh, what is the purpose of the instruction, so you can refer to these instructions, the descriptions here, and I have shared one link in the previous video. You can check the description of the previous video, part 1. There is a link available which contains all the instructions. If you are not familiar with instruction, then you can refer that link. These are the example of arithmetic operation, subtract, addition, and all. And then jump example. So jump to this location if this is equal to 1 or if this is equal to 0. Stack manipulation, push and add, then calling. And this is the example in the uh, assembly language. So these are the instruction, and this is the comment. So what is going on here is described here. So for example, here it is jumping to the end. If the CL was 0, go to end. So based on each instruction, these comments are mentioned for our reference. And if we go next, so this is the C program. So these two things are same. This is in C language, this is in um, machine language with instruction. And that's it. And this is the additional material which they have suggested here. So we can refer to these material as well. So that's it. This is the part which I thought we should cover. Ideally, it should have been covered in the previous video, but anyways, we have covered it now. So now you will resume. Now you will go to the CrackMe 3 and CrackMe 4 video. So in the previous video, we covered CrackMe 0, 1 and 0, 2, and we covered till here, and now we will cover 04 basically. And before covering 04, I just want to talk about 03. So 03 is similar to 02. Even the password is same. You can enter the same password which we cracked, where we cracked in the previous video. The same password will be accepted. The only difference in the code is that the key portion of that password in the code is mentioned in some separate function. That's it. So no other changes there in the whole binary. So it is just a matter of a different function, and the answer is same. So I will not go on 03 again. You can refer to the previous video. I will mention the link in description, and you can view the solution of 02. And now let's go to 04. And IDA Pro tool is suggested here. So let's begin. And before I start with IDA tool, I will start with radar 2 for now. Um, so R2 minus D to decompile, AA or AAA to analyze the flags, and um, if we want to directly go to main function, PDF at main, and we can see the main function is quite simple, and it is moving some 15 number to EAX registers and doing something here. It is accepting the password colon this, and these are some default function, printf and scanf. And then there is no comparison or anything going on here after accepting the password. So everything is there in the function with the name of check. So this is not a default function, and whatever whatever the decision making will happen will supposed to happen in this check function. So let's view the sim dot check function, and here we can see many things. Some variables are created at the top, and then here we can see this is the portion where password OK will be executed and the password incorrect is mentioned here. And some arrows looks like a loop, because you can see that this dotted blue line, so this is going uh, over over to the top again, so this is a loop. So let's move forward and try to understand the comparisons here. So uh, one decision making or one comparison is happening here, another is before this jump instruction, um, and then the last one here. So if we just check at very high level, so it is comparing variable C with the EAX, uh, and based on the result it is moving. So if the result is something, then it is going here, and some processing is happening. Otherwise it is directly saying the password is incorrect. So even after uh, this comparison, it is not saying that the password is correct. Incorrect loop we can see, but for um, making sure the password is correct, some additional check will happen here. And then after this comparison, it is saying the password is okay. Otherwise, it is moving here and it is going to loop, or it is saying password incorrect. So the the comparison here which is happening is happening between variable var underscore 8 and 0x f, which is 15 in decimal. So this is number 15, which we checked in main function as well. So you can see 0x15, 0xf is 15. So we can see that the comparison is happening with variable, and it is checking whether the value is 15 or not. If the value is 15, then it is saying password okay. Otherwise, it is going in loop again. Uh, and now we can check the IDA tool as well, um, how it looks like in IDA. So IDA 64, okay, crackme 04, okay with default options, okay for some warnings, and this is main function, and the main function is ending here, but we need to check the check function which is mentioned here. It is calling the check function. So this is the check function. Double click and we can see a similar pattern here. So this bigger loop is was the dotted line in R2 tool, and the password incorrect is here. And if password is not incorrect and some additional check is required, then it will go here, additional calculation will happen. Then at some stage it will say password is okay. Otherwise it will go here and it will run in loop. uh, so basically the same thing which we understood in IDA tool. One thing to note here is the um, strlen part. Let me find out where it is mentioned. Maybe in IDA tool it will be easier. Yep. So it is calling strlen, which is string length function. So it is calculating the length of the string. So most likely the input which we have provided through the main function, and it is coming down here. So it is checking the length of our input, and the similar thing should be mentioned here on uh, top. Yep, this is here underscore strlen, and basically it is doing the comparison after calculating the length. So length of the input matters, and if something is if the result of this comparison is true or false, based on that it is jumping to a different set of instruction. So this is another major thing which is playing some role here. Now, so far we have not decoded what is the password. We understood that number 15 has to do something with the password, and the length of the input which we will provide will play some role, right? These two things. So to view the decompiled version, like program in C code or any other language, in IDEA tool, we have one functionality to decompile, to view the decompiled code, and for that we need to press F5. So if I press F5, it says your copy of IDEA can decompile only x64-bit code. IDEA Pro can decompile code for many other processes. So I'm using the IDEA free version, so that's why features are limited. So I cannot use the decompiler feature in the IDEA tool. So there is a alternate, or you can use some plugins, or definitely you can buy the IDEA Pro version as well if you prefer to. That is worthwhile investing in that. So the alternate, if you want to use, is the tool Ghidra. So Ghidra is another tool. I am sure you have heard about it. I don't think I have covered in any of the previous video. So if I go to Ghidra, let's see if we can uh, view more things about this binary or not. It is loading. It requires um, um, Java code or Java function installed in your machine. So you might need to install Java, uh, the latest version, so that Gitra can run. So this is all set up. I'm launching it for the first time, so we need to create a project. I'm just creating a non-standard project, and maybe let's create in MBE directory only, and the project name is CrackMe challenges, maybe underscore. Let's put the underscore. And what else? It is not, project directory does not exist, so let's create the directory. So mkdir Ghidra in the previous directory. Let's see if it is able to detect now. Gitra, select project directory, and it is now giving us the option of finish. So finish, and now we can see one folder is created. Now we need to import the file, which is 04. Select file to import, and it is importing the file. Let's wait for a minute, and now it is showing some options. So I will keep the default settings. I'll just click to show you the options which are listed in the options section. So we'll not make any modification, and we'll click OK, and still importing and processing, and we can see some detail of this binary: number of bytes, number of function, etc., symbols, data type. And if I press OK, we can see that 04 is loaded here. To open the code browser, we need to click here, code browser. And meanwhile this is opening, let's go back to the lecture PDF. So on the next page we can see some IDE basics tips. So we can enable auto comment, we can enable opcode, we can reset the desktop, and there are some shortcuts like spacebar to change the mode, basic versus graphic. And if we go ahead, they have given the example of stack. So you can go and look at this PDF, and some animation is lost in the PDF version. So some animation was supposed to happen if we run the PPTX version, which I don't have. And then again the stack details, and then some resources. I for IDEA Pro, IDEA Pro shortcuts, IDEA Pro book, and syntax highlighting, some article from 2012, and some additional resources. So uh, nothing else is there in this PDF. So let's go back to Ghidra, and we are in the code browser. So uh, I was expecting that it will load that um, crack me 4, but let's do that again. File open and OK. uh, so it is asking to analyze it. Yes. uh, let's keep the default options. Analyze, so this is similar to AA or AAA in the R2 tool. Now it is analyzing, we can see here it is making some progress. Let's wait for it, and once it is completed we will go to this window, so we can um, see program tree, and here we can see the functions. And since this analysis is over, we can go to the main function. So this is the instruction, or in the hacks uh, mode. So this is the whole machine level code. We can click on main, and it will show us the main function. And we can see the decompiled version here as well. So this is what I was trying to run by pressing F5 in IDE. So we can use Ghidra. It is free tool, and we can see the decompiled version as well. So let's go to the check function, which is main. I mean the key function. So in the decompiled version, we can see there is a while loop. Then if else condition is here, it is just checking uh, whether var 1 is smaller or equal to local 10. And then if here again, if local underscore c equal to 15, then break, and if this break will execute, it will jump to password OK part. So the similar thing which we have seen so far, but here we can understand it better rather than the instruction, looking at the instruction. So let's try to understand um, this decompiled code. So local C variable and local 10 um, uh, is assigned with the 0 value. So then the while condition is running in loop until the result came as false. And here the strlen is getting executed for the parameter which we are supplying. So definitely it is calculating the length of the argument. So for example, if we supply a password which has 5 digit, so this will run 5 times because of the length. And then if var1 is less than or equal to local underscore 10, which is 0, uh, if it will print password incorrect. So the what is the var1? Var1 is the length of the parameter, which is 5 in our example, which we are considering or assuming. So in the first loop, the value will be 5, which is greater than 0. So it will not execute this password incorrect part, and it will continue running other instruction, which is local underscore 11, another variable, and parameter, and then the square bracket local underscore 10, and local underscore 10 is the uh, is the in the first loop it is 0. So 0 is the first index of um, any string. So what I mean is, if the password, say for example, ABCD, ABC and 123, so the first letter is at a 0 index. So we can represent it like this. So what will be the result? The result will be A, right? So uh, this is not a right syntax. It will show up error. I'm just trying to uh, translate the meaning to you. So the 0 index of this string is A. So in the first loop, uh, what will happen, that the local 11 will get assigned the value of uh, the first letter of that parameter, which is A. So this will become A. Then next, uh, it will run scanf, and then local C equal to local C plus local 8. What is local C? Local C is 0 in the first loop, plus local 8. What is local 8? Um, Local 8 is basically local 11. You can see the value is transferred here. So 0 plus A, the result will be A, and it will get assigned to local underscore C. So by looking at this operation, arithmetic operation, I'm assuming that the password should be in integer format only, so that the addition can happen, right? So if the password will be um, 5 times 1, so the first loop 0 plus 1, uh, result will be 1, and then it is checking if the local C, which is 1 in the first loop, is equal to number 15. If it is number 15, then break and go here, and password is okay. So basically, in the first loop, the value will remain 1, because our password was 5 times 1, 1, 1, 1, 1, 1. So in the second loop, the same thing will execute. The sum of first two digit will be 2. In third loop, sum of first three digit will be 3. In the fourth loop, sum of four digits will be 4. And in the final loop, sum of 5 digit will be 5. So if 5 is not equal to 15, then this is not the right password. And once the index is over, I mean, we have executed this 5 times, then this loop will then this portion will get executed, because there are no more letters remaining in our input. So what we can conclude is that the sum of all digits that we will supply, the sum of all individual digits should be equal to 15, and that will be the correct password. So there is no one single password, so we can try um, with this understanding. So crack me 4. If I supply 5 times 5 or 5 times 1, it is saying password incorrect, because sum is 5 and not 15. And if I supply, for example, 76, um, maybe 78, So the sum of these two digits are 15. So this should be the right password. And even if I type um, 1 15 times, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15, this should be the right password again. Yes. So uh, another try, like uh, 1 5 7 um, 5 4 6 6 and 7 13 and 2. So this should be acceptable. Password is okay. So anything uh, which is equivalent to 15, the sum of the digit, is the right password. So that's what we have understood using Gitra, decompiled version. But what if we had to do this using R2 tool, maybe using the breakpoints, setting the breakpoints and run the dynamic analysis. So this was the static analysis. We just looked at the instruction and decompiled code and we understood what is going on. But if you want to check the same thing here, so two things is important. So one comparison which we concluded by looking at this code as well, that the comparison is happening with number 15 and the length is getting calculated here and the comparison is happening here. So some variables are important here. So let's run this for the first time in R2 tool, DC. Uh, Let me minimize windows behind this. Okay, so DC, if it will show some signal or error, then you need to run it again, and it is asking for a password. So if I supply password 5 times 1, it is saying password incorrect. So let's set the um, breakpoint here. So because this is the final comparison, the sum of all digits should be 15. So if we set the breakpoint here, what will happen is db breakpoint and run it again using OOB. It will reload the program from the beginning. And now if we check um, the function again, the breakpoint is set at the right place. So next we can do is to execute from the beginning again, and this time since the breakpoint is set, we will be able to see what is going on. So if I press DC password, it is asking for the password, and if I supply, for example, number 2, number 4, number 5, that's it. And if I press enter, and you can see the sum is 11 and not 15, so this is not the right password. And if I press enter, the breakpoint, it says the hit breakpoint. So uh, the first loop has executed and the comparison will happen here. So let's check the value of variables. So using AFVD, we can check the details of the variables. And if I press enter, we can see at least two things here which are important. Is by looking at the value, like uh, 2, this is in integer format, this is in hex, and here we can see 2 again. So our password was 246, right? Not 246, actually 245. So the first digit is 2, um, and we can see the first digit 2 is mentioned here twice in this var underscore attach, which is getting compared here at our breakpoint with 15. So if this will turn to this. If this will be equal to 15, then the password OK will get printed, and we can see uh, number 2 here as well, which is var underscore 4. And if we check var underscore from the bottom, we can see var underscore 4 is getting moved in EDX, and before uh, this var underscore 4 is uh, moved in EX, or some relation is here, and we can see the var underscore 4 again nowhere. So you can see the var underscore 4 is mentioned here, and if we check the similar thing in IDA as well, if we go back to IDA and if we check the var underscore 4, we can see the similar thing. It is getting moved to EX, right? And nothing special. We can see var underscore is -4. That is fine. That is by default. Uh, so till here, nothing special for var underscore 4. So we can park that it for now. Okay. And if we move forward, um, like executing it again, continuing with the flow, and it will um, run one more time because we had 3 digits in our password. So what will happen? Hit breakpoint again, and if we check the value of the variables, it is showing 4 here and 6 here. So the 4 is printed here. So in var underscore 4h, what is getting printed? Uh, the the value of the digit, like so. In the second loop, the index value of 1 is getting stored here. So remember, in Ghidra we have seen that the index uh, the index uh, is calculated, and the arg and the digit of that input is getting stored here. So if the index is 0, or in the second loop if it will turn to 1, then the input, which is 245, so the number 4, the second digit, will get selected, and it will get stored in the local underscore 11, and then local underscore 11 gets transferred to local 8, and local 8 plus local C is getting executed. So basically the first 2 digit will get added, and in the next loop the last digit will get stored in the var underscore at var underscore 4 or local underscore 8, whatever you call it. So previously 2 was stored, and 4 plus 2 came as 6, and 6 is not 15. So, and there is one more digit remaining, so one more loop will get executed, and if we check the value again, now we can see the last digit is 5, and it get added to 6. So 6 plus 5 is 11. This is not 15, and since there is no more digit available in the supplied password, it will terminate the program. So if I press DC again to continue, it says password is incorrect. And let's try it with correct password now. So reload it again, and if I press DC, it will ask for password. Let's apply um, the same value, similar values like 2, uh, 4 and 5 we supplied previously. So 4 plus 2 is 6, and if we supply 9 here, so 6 plus 9 will be 15. Yep. And if I press OK and hit breakpoint, the first breakpoint is hit, so we can check the value of the variables. So the first value is picked, 2 and 2, and in the next uh, loop it is showing us 2 and 2 again for some reason. I thought this will get added here. 2 plus 2, 4. Anyways, let's run one more time. And strange, huh? So I think something happened here. Don't know why this is behaving like this, but this should not be the actual result. So let's exit once and let's reload one more time from the beginning just to make sure that there is no corruption in memory or in the running process. AFL, and let me close this window just to free up some memory, and we can close the IDA as well. We are done with the IDA for now. Don't save. Okay, and go back. So PDF at simmer.check. Let's set the breakpoint, which is this TB paste. Let's check one more time. The breakpoint is set. Looks good. So type DC. Password is 249, which is equal to 15. Hit breakpoint. This is the first loop. AFVD number 2 and number 2. AFVD again and again number 2 and number 2. I'm really lost now. I'm sure you might have noticed that for some reason I was just executing the AFVD command and checking the value, but I have not actually executed the DC command again. So my bad, I completely missed it. So we are at the first loop only. So the first digit is 2 and the sum of all digits is 2. That's why it is just showing 2. So I need to type DC, hit breakpoint, and now the second loop will get executed, and the second digit is 4. The sum of first two digit is 4 plus 2 is 6. And then the last loop, and if we check the value again, so uh, the previous value of variable was 6. 6 plus 9 is 15, and now the comparison will happen of var underscore 8, whether var underscore 8 will be 15 or not. So now we have reached to this stage, and this comparison will get executed, and it will uh, move to this part rather than moving to this loop. And you can see once this part get executed, it will exit the program. So these instruction will not get executed. So let's run it again. DC, and it says password is okay because this 15 is equal to the number 15 which was supplied above. So this was all about CrackMe 04. I hope you have um, understood the concept. So in IDA Pro tool as well, we can see the decompiled version. We can see the decompiled version in Ghidra as well. This is another powerful tool. Um, and at the same time we can experiment with the dynamic analysis using R2 tool, and the dynamic analysis can be done on these tools as well. So there are options to set the breakpoints and all. So I'm not familiar for now both using IDA or using Ghidra. I will try to cover these concept, how we can do the dynamic analysis using these tools. But till then, I feel this R2 tool is comfortable to do the dynamic analysis. Uh, the concepts can be understood easily, and if we see more loops and more conditions, and if this looks very complex, then we can anyways check the flow in the IDA tool or the decompiled version in the Ghidra. And if you don't want to look at the decompiled version like this, and you want to check the flow chart or the program flow or the visual graph, whatever you call it, you can check this in Radar 2 as in IDA. So for that, the command is double V, I guess small v will work. So if I press enter, uh, it shows the hex version here and the registry and uh, the register values. If I press capital V, not in a function, so exit by pressing Q. So the capital V will work. The only difference is that we need to move to the right function before we run V to view the graphical mode. So uh, we can check all the function list using AFL, so all function list, and we can go to these addresses, or we can type s space main. This will move us to the main function. So as for seek to the main function, and then if we type double V, then we can see the diagram. So for the main function there is no diagram because everything is happening in the function which is check. So press Q twice, and if I go to seek sim dot check, and if I run double V capital, and here we can see the flow which we were able to see in IDA tool as well. So indeed R2 tool is also having lots of features which are not explored by myself, and we can do many things in all the tools. Basically all tools have uh, more or less all the features. So just a tip, uh, wherever you are comfortable, you can use that tool to decompile the assembly, and keep on learning other tools as well. If you have liked this video, please like and subscribe. It will uh, encourage me to record more videos, and I will keep covering this course in the series of videos, and we will cover all the challenges which will come in the future lectures. So thanks, have a great day, enjoy, have a great weekend, bye bye.